what's called the distance formula. So we'll start with the distance formula first. Now, in analytical geometry, you may be asked to find the distance of a line segment. Okay? Now, you need to know how to calculate it. Fortunately, there is a formula which originates from the Theorem of Pythagoras. Okay, so if I draw my Cartesian plane, okay, if I draw a straight line on this Cartesian plane, let me call it AB. Right, so that's my straight line there. Obviously, this is my y-axis, that's my x-axis. Okay, if I draw a line segment on a Cartesian plane like this, in analytical geometry or coordinate geometry, you may need to know the length or the distance of that line segment. So you'll be given coordinates. Let me call that point A, where you know an x value, which I'll call XA, and a y value, which I'll call YA. Okay? So we have got point A there. Then we have point B here, whereby we know the x value is XB, the y value is YB. Right? Now, since we are given coordinates, there is no direct formula that you can use as is like this to calculate the length, except measuring it using a ruler. That's the only one. Okay? But we can create a right angle triangle by drawing a line which is parallel. Okay, please, I'm just showing you the derivation here. Okay, I'm doing the derivation of the formula because I just want you to know where the formula comes from. Right? So we can draw a line which is parallel to the x-axis up to point A, up to the x value at point A. So if I draw a line from point B, like that, and then I draw a vertical line which is parallel to the y-axis, okay, and then I'll create a right angle triangle like that. It means that I can now use the theorem of Pythagoras. Now be aware that at this point, the value of x, okay, here is going to be XA. The value of y is going to be YB. Okay? Okay, maybe we can call this point, let's call it point C. So at C, the value of x will be A. The value of y, it will be YB. Is that clear there? Huh? Right. Then, since we now have a right angle triangle, we can use the theorem of Pythagoras. So, let me move on to the next page because I don't get space. So if I use the theorem of Pythagoras, so I'll say in triangle ABC, if we use the theorem of Pythagoras, I'm going to have AB squared is going to be equal to, well, in this case, if I want to start with XA, with XA minus XB, so I'll say CB squared, okay? CB squared. So that will be CB squared plus, right? If I want to start with YA, then that will be AC squared. So AC squared. This is Pythagoras. Right? Now, I'm going to replace I'm going to replace now. You see, in this case, I want to calculate the length of AB. So AB will remain as is. CB now. Remember, when I taught you the formula for horizontal distance, remember, for horizontal distance, whereby I said the horizontal distance is given by x maximum minus what? Minus x minimum. So the length of CB, okay, in terms of x, it will be equal to XA minus XB. Okay? So we can write this as XA minus XB squared plus the length of AC, it's a vertical distance, so it will be Y maximum minus what? Y minimum. The Y max is YA, the Y minimum is YB. So this will be YA minus YB squared. So this is the length of AB squared. Then, if you want AB, we take the square root. So AB will be the square root of XA minus XB squared plus YA minus YB squared. Now, this is the famous distance formula, okay? But I'm going to generalize it, but you can write like this, okay? Whereby we can say AB, we can call it any distance D, okay? So if I call AB any distance D, means D will be equal to the square root. If I call that XA, say, okay, I prefer to use the subscript like X2, okay? So if I call XA my X2, here I'm generalizing, okay, the formula. So this will be X2 minus X1 squared plus Y2 minus Y1 squared. Okay, so this will be the famous distance formula that you use to determine the length of any line segment. Right? Now I want you to take note here. With regard to the subscript, if you start with X2 here, then you also have to start with Y2. You can also start with X1 and have it as X1 minus X2. Then on this Y part, it becomes Y1 minus Y2. Okay? So this is the famous distance formula, which you will encounter for the next coming, say it's 2 years up to matric. Okay? It's going to be there in your November examination. Okay? So this is your distance formula. Now, sometimes you may also need to calculate or to know the coordinates of the midpoint of that line segment. Okay, so there are times when you may need, so what I'm going to do is I'm going to duplicate this page. Okay, fortunately, technology is very nice. I'm going to duplicate, then I will drag it down. Okay, it's this one here. So I'll drag it down like that. Okay, so I'm going to use it as well. So I'll erase here and write a new heading. That will be midpoint formula. Okay? Midpoint formula. Okay, so we must write a new heading. Midpoint formula. Midpoint. Okay, so there are times, okay, besides finding the distance, we may need to know the coordinates of the midpoint of the line segment. Now, this is quite interesting because I'm taking you back to the foundation of the formula. Okay, let's say I want to find the midpoint of this formula here. Let me maybe say the midpoint is here. It's somewhere here. This is very interesting. Okay, let's say the midpoint of that line segment is there. Now, I'll represent it by M. Okay? It is very much possible to determine the midpoint of that line segment using the values of x and y. That is the coordinates of A and the coordinates of B. So this is how you can do it. But I want you to pay attention carefully because it can be a little bit tricky. Right, so at this point, we don't know the value of x. We don't know the value of y there, but we want to calculate it. Right? So if I want to calculate it, I have to use the coordinates of A and the coordinates of B in order for me to calculate it. Right? Now, do you agree with me that for me to be able to do that, I need to use the horizontal distances and the vertical distance for me to do that. So this is how you can do it. If I want to calculate the midpoint of this line, it means I may need to know what is the x value here. Sorry, the y value here. Right? And I also need to know what is the x value there. Am I right? Huh? So if I want to know the x value here, the distance from here to B, okay, well, you may have to calculate that distance, right? Also, the distance from this point, say, to point A, you may have to calculate that. But the easiest way would be okay, so if I want to calculate the y value at this point here, all I have to do is I can add this y value and this y value. If I add the two, right? Remember, what is ya? Where does ya start from? Ya starts from this point. You agree with me there? Please raise your hand if, okay, I'm just doing you a favor, otherwise I was supposed to just say, learners, the formula for calculating the midpoint is this, then I stop. So what I'm doing here, I'm doing a lot of favor because I want you to understand where the formula comes from. And that will help you better in understanding what's going on. Do you agree with me? You must raise your hand that YA starts from here up to that point. Raise your hand if you understand that. Okay, put your hand down. All right, look here. If AC is perpendicular to BC, it means that the angle here is also what? 90 degrees. Right? So the distance from this point to A, it will be equal to whatever the value of y is. If it's a 6, if the value of ya is a 6, means the distance from here to there, it will be 6 units. Also, from the origin to a point which is on the same line as point A, it will also be 6 units. That's common sense. Okay? That's common sense. Right? Then, the distance, or rather I would say, YB is from here up to there. You agree with me there? So if I want to calculate the midpoint of AC, okay, all I have to do is add YA plus YB and then get an average. So it will be YA plus YB over 2. If I want to calculate the X, so whatever value I get here for Y, it is the same as that. Yes, it is the same. If this point is on the same straight line as point M and the line is parallel to the x-axis, then means the Y value here will be the same as the Y value there. If you can't see that, then something is not okay. Right? Also, for the X value, do you agree with me that XA starts from here up to there? It also starts from the origin up to there. Do you get that? And then XB starts from here up to point B. It also starts from the origin up to a point which is on the same line. Which if that line is parallel to the y-axis, so it will be somewhere there. So again, if I want to calculate the midpoint of BC, it will be equal to XA plus XB all over 2. Okay? So let me just generalize this. So I'll go to the next page. So the midpoint formula, which we generally write, we represent the midpoint formula by capital letter M. The midpoint, it's a point. Please take note of that. So you can't say M is equal to at this stage. So based on our diagram, it will be equal to the X value at the midpoint will be equal to XA plus XB over 2. The Y value will be equal to YA plus YB over 2, which I can generalize and write as M by use x1 and x2, divide that by 2. That's the X value. The Y value, it will be Y1 plus Y2 all over 2. Okay, so this is the famous distance midpoint formula. That one, which you are going to use a lot. Okay, please take note here that I started with x1, you can also start with x2, right? And here I started with y1, you can also start with y2. Okay, I don't want you to think that you have to start with x1 all the time, y1 all the time, because that's not entirely correct. Okay, because the identification of x1 and x2, it's a choice if you are given a line segment. All right. So now that I've introduced this, then let me move on to okay, the equation of a straight line, right? Calculating gradient is just repetition of some of the things that we did under functions and graphs. So that should not take us too long. So equation of a straight line. Equation of a straight line. So the general equation, you know, is y equal to mx plus c, okay, where m is equal to y2 minus y1 over x2 minus x1. It's also equal to y1 minus y2 over x1 minus x2. Right? C is the y-intercept. This is the y-intercept. Okay. So you should know that. So I'm not going to talk much about this because we've been doing it recently. In analytical geometry, you have to apply your knowledge of the equation of a straight line. Yes. Right. Then let's move on to parallel lines. Okay. I've done that already under functions, but I have to do more like a recap here. Everything you need to know about straight lines, it applies here. Like, okay, parallel lines. If two lines are parallel, let's say this is L1 and that's L2, and the two lines are parallel. You should know that if L1 is parallel to L2, it therefore means that M1 will be equal to M2. It means that the gradients are equal. Okay. If any two lines are parallel, their gradients are equal. Then perpendicular lines. Please, you must use the ruler. I didn't use the ruler. That's why. Perpendicular lines. This is very important. It's a very important concept. Okay, I need to move on over my time. Perpendicular lines. Right. If two lines are perpendicular, okay, two lines are perpendicular, if you determine their gradients and multiply them, you always get a product which is equal to -1. So if I have a line here, if I call it L1, then if I draw another line, and I call it the figure, I don't need to put lines that are parallel, it's a mistake there. Let me check it out. So if the two lines are perpendicular, okay, what this means is that L1 is perpendicular to L2. Therefore, M1, remember M stands for gradient, right? M1 times M2 will be equal to -1. That's also very important. Okay, so this is L2. Okay, vertical line. If I draw a Cartesian plane and if I draw a line, okay, before I carry on, first thing, by now we should know that the y-axis has an equation, and that equation is x equal to 0, right? It's a vertical line. Then, let's say the value of x here, maybe it's a. The value of x there, it's a b, right? If I draw a vertical line, then I think that I draw a proper vertical line. If I draw a vertical line passing through A, like that, okay, and I draw another one passing through where x is equal to b, like this, I can write equations, okay, for both lines. So the first one, to the far left, the equation here, it will be x equal to A, right? The one to the right hand side of the y-axis, it will be x equal to b. Then, if you're asked to determine the gradient of both straight lines, the gradients are undefined. So M is undefined. M here, for the next line, M is undefined. Okay, any vertical line has no grade. The gradient cannot be defined. You can't give it a value, right? Then horizontal lines. You can catch up later. Okay. Horizontal line. First, before we go anywhere, you need to know that the x-axis is an equation, and the equation is y equal to 0. Okay? So if I call this point here, maybe let me call it A, and that point call it point B. If I draw a horizontal line, like that, and then another one. Okay, these two straight lines have got equations. Okay, and the equation for the top one is y equal to A. For the bottom one, it will be y equal to B. Okay, their gradients are equal to 0. So the gradient of the x-axis is 0. The gradient of y equal to A is 0. The gradient of y equal to B is 0. Any horizontal line has a gradient which is equal to 0. Okay, quickly call in your points. Call in your points. What I'm going to do here is if I draw a straight line, say that line there, and then I put maybe say 3 points, okay, 4 linear points. Right. Please, can you write this down before we draw the Cartesian plane? Or anyway, let me write it down here, what collinear points are. Collinear points are points that lie on the same straight line. They lie on the same straight line. Okay, so if I have point A here, I put point B there, maybe point C, and then D. Right? If those 4 points are collinear, what that means is the gradient of AD, for example, it means that, so let me do this color. It means that MAD will be equal to MAB, will also be equal to MBC, and that will be equal to MCD. Okay? Furthermore, it's also equal to MBD. So if the points are collinear, you calculate the gradient of AB, it must be equal to the gradient of BC, CD, BD, AD. Okay? So if let's say you are given the coordinates of A, coordinates of C, coordinates of D, and you're asked to determine the gradient, right? You're given 3 points on the same straight line. It is your choice to decide any of the 2 points to calculate the gradient. So if you're given the coordinates of A, C, and D, you can choose A and D. You get the same gradient if you choose the coordinates of C and D. So if points are on the same straight line, we say they are collinear, which means that if you calculate their gradients after choosing any pair of points, you get the same gradient. Okay? So I think I'll stop there.